We are going to discuss an example of an entity relationship diagram, and then we will discuss how this ER diagram can be converted to relational schema. That means how tables can be created using this ER diagram. For example, here car is an entity and car is sold by an employee. That means if you have a showroom, then a car is sold by an employee and a car is owned by a customer. That means he is selling his car to a customer, and for that he is generating an invoice and this customer is getting that invoice. That means here four entities are there. A car, suppose that you have the car is manufactured in a company and that is shown in a showroom, and suppose that a customer is coming and he is going to buy this car. That means then he has to approach an employee, and in that case this employee is generating an invoice and that is giving to the customer, and at the same time this employee is selling this car to the customer or handing over this car to the customer. That means here car has a customer or customer has a car means this customer can have multiple cars. There is no restriction for a customer to buy the number of cars. Okay, a customer can have many cars, but here one restriction is here this employee is selling this car to some customer, and for at this point in time, our assumption is that he is selling that price to a single owner. That means customer is a single person. So he is selling that. So this car is owned by a single customer. That is why you have an n by 1 relationship. That means one customer and many cars. Or a car cannot be owned by more than one customers. So that's why you have n here and 1 here. That means n to 1 relationship. A customer can have many cars, but a car is owned by a single customer. Okay. Now, an employee is selling car. This employee is selling a car means he can sell a number of cars, but a car is sold by a single employee. A car is sold by a single employee, whereas an employee can sell many cars. Okay. So that's all about these things, this relationship. Then employee and invoice. Employee is generating many invoices. Employee is generating many invoices, and these invoices are given away to many customers. That means, but if you have an invoice, then that invoice is given away to a customer. That means a single customer can get or can receive many invoices, and at the same time this employee can generate multiple invoices. So that's all about this thing. That means here has a relationship is there, has a relationship, here also has cell. So to distinguish between these three relationship, this is has 1, this is has 2, and this is has 3. That means to distinguish between these relationships. Okay. Now what we are going to do is here we have to generate. So for the car entity, you have multiple attributes like car ID, model, and serial number. This car ID is the primary key here. That means car is having the relationship is car. Car is having car ID, then model. Model is having color and year. So we are going to have color, year, and say serial number. So these are the attributes associated with car. What about customer? Customer is having customer ID, name, address and city. Address, city. And now we are having employee. Employee is another entity. Here we have employee ID, name, address, qualification. Employee ID, name, address, qualification. Name, address, qualification. And the last one is invoice. Invoice, which is having date and invoice ID and date. Okay, so these are the entities. That means 4 entities are there. They are identified. That means you are going to have schemas like this. That means tables which are having car ID, color, year and serial number. In that case, we have chosen this car ID as a primary key. Customer table is having 4 attributes: customer ID, name, address and city. Among this, customer ID is chosen as a primary key. Then employee table, employee ID, name, address and qualification. Here employee ID is chosen as the primary key, and invoice is there. In that case, invoice ID is here. Invoice ID is the primary key. Now we have a relationship. So I want to have here has a relationship. That means here a customer has a number of cars and a number of cars are owned by a customer. So either you can have here you have a table like, say, you can have a table like this is car ID and customer ID. That means primary key of this table and primary key of this table you can have. That means you are connecting. That means this car having this car ID. For example, suppose that this is XXX and this is YYY. The meaning of this is the car which is having car ID XX is owned by a customer who is having customer ID YYY. So a separate table you can have. A separate table you can have for this relationship. But if you want to simplify things, what you have to do is instead of having this, you can transfer this customer ID to this side. That means this is n-to-1 relationship. This is a n-to-1 relationship. Here you are having a car entity and you have another customer entity. Customer entity is having customer ID as the primary key, and for car ID is the primary key. That means a car is having a single owner, whereas a customer is having multiple cars. That means instead of having, you can achieve this using, that means has a relationship. That means here you are connecting your car ID and customer ID. Car ID, if he is owning 10 cars, then there are 10 entries with YYY, 10 entries with YYY, etc. That means this is a kind of redundancy. Okay, that means duplication of information. So in that case, if you have a n-to-1 relationship or one-to-many relationship, that means many-to-one or one-to-many relationship, what you can do is instead of having a separate table for this relationship, you just transfer this customer ID to this entry. That means here I am going to add one more attribute to this. That means these are the attributes owned by car, and here you are going to add this customer ID also here. That means customer ID. That means this car is having this car ID is owned by this customer. That means if you do that, that means this is many side and this is one side, and from the one side you are shifting this primary key to this side. That means customer ID is added to car. So now this is over. We now we are not, or for this has a relationship, there does not exist any tables. There does not exist any table. Why? Here we have transferred this customer ID to this. So if you want to transfer this kind of thing, one thing you should remember, for many to many relationship this is not possible. Many to many relationship this is not possible. Here also for has to, I am going to have has to relationship. If you want has to relationship, then you should have customer ID and invoice ID. That means for this customer ID and invoice ID, that means if this customer is receiving invoice and suppose that he is getting 10 invoices, then there should be 10 couples with the same customer ID, different invoice ID. So in that case, what I have to do is, as I told you, or what we have done here, like that, this is one side and this is the many side. From one side you have to copy the primary key of that side, and that attribute has to be shifted, or that has to be included in this side. That means in invoice you are going to have, again you have added customer ID also here. Now invoice ID, date and customer ID. That means this invoice is given away to this customer ID. Here customer ID is not unique. Why? This is not a primary key here, but actually it is a foreign key. That means customer ID is a key for another table, but here this is a foreign key. Okay. Now this has to relationship is not needed. And what about has 3? Has 3 relationship. Here has 3 relationship. Here also you are going to have a table. That means that is having employee ID and invoice ID. So employee ID and invoice ID. That means employee ID is giving this invoice. Who is generating this invoice? An employee who is having employee's ID, this one. He is generating an invoice with invoice ID, this one. So has 3 relationship. For any relationship, or for all relationships also, you are going to generate tables. But here in this case, what you are going to do is, you are shifting this employee ID to this side. That means you are going to add this employee ID also to, that means this is the one side and this is the end side. We are shifting this employee ID also to this invoice, and now we are going to have customer ID, EMP ID. That means here this invoice has taking part in 2 relationship. In those 2 relations, the end side is in the invoice side. That is, you are adding customer ID here, employee ID also here. Now the invoice is having an invoice ID that is generated by an employee with employee ID this, and it has to be given to a customer who is having customer ID this one. Okay. Now what about the cell relationship? Here also you have 1 to n. That means from one side this has to be shifted to the car. That means here employee ID. So car is having employee ID also here, EMP ID. Okay. That means here in this case we have only 1 to many relationships. In this case we have only 1 to many relationships. But if you have many to many relationships, for example, if I am having, say, this is student and here course, and this is a relationship enrolled student enroll course. That means this is N and this is N. Why? A student can participate in multiple courses and a course can have multiple students. That is one to many relationship. So suppose that we are not interested in this is roll number. Suppose that roll number is the primary key here, and suppose that the customer ID or course ID. Course ID is the primary key here. Course ID is the primary key here. So if you are if you want to connect these two, you should have a table called enroll, which is having these two primary keys, a roll number and course ID. Meaning is a student having this roll number is enrolled to a course which is having course ID this one, and like that. Okay. So here this is a relationship, this is another relationship, this is another. So we have four relationships. So here in this case, we have succeeded in shifting or we have succeeded in eliminating these relationship tables. Why? In all these cases, we have many to one or one to many relationships. But if you have many to many relationship like this, you cannot avoid making relationship tables. In that case, you should have, this is a table which is implementing this relationship. So here n to n, many to many relationship. In that case, you need a separate table for this mapping. But if you have one to many or many to one relationship, in that case, by careful shifting of primary key to the other side, you can avoid tables representing relationships. Okay, thank you.